Hi, welcome to question 12 of the 2024 Junior Cert Higher Level paper. So question 12 is like sequences and series, so let's get stuck in. The first three patterns in a sequence are shown below. Each pattern consists of white squares and shaded squares. And we see in this first pattern, there's like 5 white and 4 shaded. And in this next one, we see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 white and 5 shaded. In the next one, there's 6 shaded. Now this is 19 white. Okay, so there's definitely one more shaded. So look, there's 5 by 5, so we're going to go up by 6 by 6. Now, just make grade. Okay, obviously you should use a ruler. So we'll split this in 6. 1, 2, 3, and 6. Okay, and the pattern now is shaded, shaded, the diagonal, and this one up in here is stretched further away. So there should be 7 shaded and a whole pile of white. But I'm not all that worried about it. The pattern looks like it is the iteration. Now in the notes I put in that's the one. So it's not that bad a pattern to extend, okay? And it's just a matter of being careful and making sure you don't have to make a second attempt at it. But feel free, if you do need to make a second attempt, make a second attempt. So in the part B, it says complete the table to show the number of shaded squares and the total number of squares in the sequence. Give your answer in the last row in terms of n. So we saw with the first one there, the number of shaded squares, we rewrote it there, was 5 white, 4 shaded. So we see for the first one here, there's 4 shaded squares and 9 total squares. So we'll flick back. In the second one, there's 4 by 4 is 16 total and 5 shaded. Okay, in the next one after that, there's 5 by 5 is 25 and 6 shaded. So 6 shaded, 25. Now I see the pattern. 7, 49. No, let's double check that. 36. Okay, 36. And then 8. So you see the pattern. 3 threes is 9, 4 fours is 16, 5 fives is 25, 6 sixes, 7 sevens is 49. So the number of shaded squares, now how do we describe that? Well, the pattern 1 was 3. So if we're calling that n, well, n plus 3 is 4. Pattern 2 is n plus 3 would be 5, so it's cool. So the pattern there seems to be n, so whatever, plus 3 to give 4, plus 3 to give 5, plus 3 to give 6. So it's n plus 3. So that's that. Okay, and the give is the other one filled in. N plus 2 ought to be squared. Okay. So in part C, part 1, it says in pattern K, the difference. Now, the difference of something would be subtraction between the total number of squares and the number of shaded squares is 271. So we know the total number of shares is n plus, let me go back and double check that. I think it was n plus 2 to be squared. Okay, now the difference, so the total number of shaded squares, the difference between that and the shaded n plus 3 is 271. Now this creates an issue in that we have to expand this n plus 2 squared. So n plus 2 squared means n plus 2 multiplied by itself. I can do the fast way or break it down, but the fast way would just be a matter of multiplying n by n is n squared, n by 2 is 2n, and then the second term 2 by n is 2n, 2 by 2 is 4. So you're making sure that you multiply everything by everything else. 2n plus 2n is 4n plus the 4. So this and this are equal, so we can swap them out. So we've just, in a way, presented it in a different form. Now, as I go left to right, minus times n is minus n, minus times 3 is minus 3. That's equal to 271. Now I can combine like terms, so there's only one n squared, so that just copies over. 4n take away n is 3n. 4 take away 3 is 1. Okay. Now I want everything on once. Oh, no, that's cool. Okay, now the assumption there is n is equal to k, so k squared plus 3k plus 1 is equal to 271. Okay, that seems to be pretty legit. I'll just check the answer on the next page. So again, now just on the next page, just to illustrate the difference, that n plus 2 squared, I wrote it out in more regular form, and then wrote out one of the brackets twice. I always pick the second, and the first term in front of the first bracket, second term in front of the second bracket, and then left to right and multiply, just like we did. So what I did within the question is kind of the faster way, but it's more error prone. So it's up to you which decision you make. And then I just swapped back in and then did the simplification down. And then I had to remember that we were talking about n, but the question here mentions k. Don't know if it'd make all that much of a difference if you just kept it as n, but just to cover the proverbial, I made that statement and then dropped it in. So that's part C, part 1. Okay. Now C part 2 says solve the equation k squared plus 3k plus 1 is equal to 271. So if you recognize this, this is a quadratic, okay? And a quadratic, everything is on the same side. So the first thing to do is get rid of this 271. Now I'm going to take it away because that'll do it. If I do it to one side, I have to do it to the other. And that'll leave me with k squared plus 3k. Now 1 take away 271 is minus 270 is equal to 271 take away 271 leaves you with nothing. Now this is a quadratic. I could swap it for x if I felt more comfortable. X squared plus 3x minus 270 is equal to 0. And the reason I might do that is to compare that to the general form of a quadratic, which is given to you in the maths tables, along with the quadratic formula, which is presented like this. Okay. Now, the reason I did all that was this quadratic here, okay, I'm going to compare that to the general form, and I can see that the a in front of the x squared corresponds to the number, which in this case is 1. The b here corresponds to this number, which is 3. And this c corresponds to this number, which is minus 270. Now, what I'm going to do now is swap them out in the formula, and I'm going to run out of space. Minus 3 plus or minus the square root of 3 squared minus 4 times 1 times 270 minus 270 all over 2 by 1. So I've just swapped the numbers instead of the letters. So instead of b, I put 3. Okay, that happened again. Okay, then the a value, goes in up here and down here. So I swapped out the 1 and the 1 in brackets. And then the minus 270 goes in here. And we're at this point. So I'm just going to use the answer in the notes if I can find it. Okay, so we end up at this point. Okay, now at this point you can put in the calculator with the plus, and I got 18, or then in backspace and replace that plus with the minus. Okay, and do it again. Just press the button again and get the x is equal to 15. So these are the two values that satisfy that particular equation. Okay. Now I assume we have to declare one of them actually didn't put that in there. This would probably be the preferable answer because it's positive, but I'm not sure if that's actually been asked. We're just asked to work out the value of k when I asked to declare which one is which, so that's probably okay. Right, so that's question 12. As always, if you want a copy of the notes I'm working off, send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. And see you on question 13.